Picture awakening in a realm where one single breath doesn't merely pain you, it annihilates you. On certain planets, your lungs would become frozen solid before you could complete taking a breath. In some places, the atmosphere exerts a pressure greater than that found in the deepest ocean trench on our planet. In certain areas, the sunlight is so extreme it can fry you more quickly than any furnace ever constructed by humans. The solar system appears serene and stunning from a distance, but when examined closely, it serves as a harsh environment governed solely by the principles of physics. Every planet, and even many moons, has its own unique signature of death, a distinct way it overwhelms the human body. Today, we're exploring those deadly possibilities through the lens of real planetary science. This video isn't built on sci-fi exaggerations. It's grounded in actual NASA data, real atmospheric chemistry, authentic gravitational measurements, and peer-reviewed research condensed into gripping visual storytelling. If something in this video kills you, rest assured, it's scientifically accurate. We'll travel from Mercury, where stepping into sunlight feels like opening an oven powered by a miniature sun, to Venus, a planet so hostile it crushes metal spacecraft within minutes. We'll fall into Jupiter's endless hydrogen storms, where pressure increases so violently that even the strongest materials on Earth would collapse. And then we'll venture into the silent outer worlds, where the cold is so extreme it pushes the limits of what freezing even means. There's only one rule on this journey. You have no spacesuit, no protection, no second chances, only you and the harsh, relentless essence of every world. Prepare yourself, as by the end, you won't only learn how each planet can be lethal, you'll grasp the science behind every horrifying moment. Let's start with the planet nearest to the Sun. Mercury. Mercury may look calm from a distance, grey, cratered and silent, but that calmness is a lie. Landing here is like stepping into an oven powered by a nuclear reactor. With almost no atmosphere to shield you, the sun becomes a weapon and the planet offers no mercy. Upon reaching Mercury's daylight side, you enter the harshest sunlight that the human body could possibly endure. The sun is over 10 times brighter than on Earth, and surface temperatures reach an astonishing 430 degrees. The instant you reveal your eyes, the severe radiation scorches your retinas almost immediately. Your skin starts to form blisters in seconds, and your sweat, your body's natural way to cool down, disappears quicker than you can generate it. In 15 to 20 seconds, heat stroke starts to impair your organs. Your heart pounds, your mind becomes overwhelmed, and you faint rapidly as your body temperature rises uncontrollably. Your blood doesn't boil, your skin keeps your internal pressure stable, but hypothermia kills you faster than any desert on Earth ever could. On the night side, the experience is the complete opposite, but just as deadly. Mercury, having nearly no atmosphere, is unable to retain heat, transforming the surface into a cryogenic freezer. Moisture on your lips and eyes freezes instantly. Every breath feels like drawing in needles as the frigid thin air harms your lungs. Your body loses heat so quickly that hypothermia can cause your organs to fail in just minutes. It's not intense, it's a subtle, gradual fading of existence in complete obscurity. Regardless of whether it's day or night, you are overwhelmed by strong radiation. Mercury's almost non-existent atmosphere offers minimal defense against the solar wind. Without protection, you'd be exposed to a fatal amount of radiation in just minutes, contributing to the planet's unwelcoming nature. Ultimately, Mercury presents two options: burn to death in relentless daylight or freeze to death in a breathless night. In any case, the tiniest planet in our solar system eliminates with ruthless precision, quickly, silently, and without doubt. Venus. If Mercury is an oven, Venus is a full-scale industrial furnace wrapped in a planet-sized pressure chamber. People often call Venus Earth's sister, but the truth is far darker. Venus isn't our sister world, it's our evil twin, a planet that shows what happens when nature takes every hostile element imaginable and cranks it to maximum. The moment you step onto the surface of Venus, the environment begins killing you from every direction at once. The atmosphere is a suffocating mix of 96% carbon dioxide, thickened to the point where breathing is impossible even before the pressure hits you. Above you, permanent clouds of sulfuric acid swirl like a toxic ceiling, and beneath your feet, the air itself feels more like a liquid than a gas. The pressure alone seals your fate instantly. At 92 times the air pressure on Earth, standing on Venus feels like being crushed under the weight of an ocean, a full kilometer of water pressing down on every inch of your body. Your lungs collapse before you even attempt a breath. The air inside you is forced out violently, your ribcage compressing as if squeezed by a hydraulic press. Any pockets of air, sinuses, stomach, intestines, implode under the enormous force. You would be dead before you could inhale even a molecule of Venusian air. Then there's the heat. At about 465 degrees Celsius, Venus is hotter than Mercury, despite being farther from the Sun. That's hotter than the inside of a pizza oven, hot enough to melt lead and aluminum. Exposed skin would burn instantly, but it's not just the outside temperature. Your internal organs begin to fail almost at once. Even after your heart stops, the extreme heat keeps cooking your body like meat sealed inside a pressure cooker. This temperature doesn't come from sunlight alone, but from a runaway greenhouse effect so powerful it turned the entire planet into a thermal prison millions of years ago. And we haven't even mentioned the acid yet. The clouds above are filled with sulfuric acid droplets, and while you wouldn't melt into a puddle like in a sci-fi movie, the acid would certainly blind you and burn any exposed tissue. Your eyes, lungs, and skin would all be damaged rapidly. The only reason the acid doesn't have time to finish its job is because Venus's pressure and heat beat it to the punch. What makes Venus uniquely terrifying is that it doesn't rely on a single factor to kill you. Every part of the planet is lethal. You're being crushed, cooked, burned, suffocated, and chemically attacked all at once. Venus doesn't offer a slow death or a quick mercy, it erases you. Out of all the planets in the solar system, Venus may very well be the worst place you could ever stand. Mercury kills you with temperature. Jupiter kills you with pressure. But Venus? Venus kills you with everything. Earth's moon. Having endured the overwhelming blaze of Venus, the moon may appear tranquil in contrast, calm, luminous, and recognizable. However, the moon's threat arises not from aggression, but from the total lack of the essentials that sustain life. Without any atmosphere, walking onto the moon's surface unprotected is akin to stepping straight into space. As soon as you're uncovered, the vacuum strikes. You attempt to breathe, yet there's nothing to take in. Your lungs are unable to take in air because there is no air present here. As the pressure approaches zero, the moisture in your mouth, throat, and lungs begins to evaporate nearly immediately. It's not boiling, it's evaporation caused by the sudden lack of pressure. Within 10 to 15 seconds, your brain runs out of oxygen and you lose consciousness. And here's where Hollywood gets it wrong. You don't explode. Human skin is incredibly strong and flexible, perfectly capable of keeping your body intact even in a vacuum. You'd swell slightly, your veins and capillaries would strain, but you remain whole. As for temperature, the moon swings between brutal extremes, about 127 degrees in sunlight and 173 degrees in shadow, but you wouldn't live long enough for temperature to kill you. Vacuum suffocation gets you first, long before the heat or cold can finish the job. In the end, the moon kills quietly. No flames, no pressure, no storms, just the silent, airless void and a peaceful, rapid loss of consciousness. Mars. Mars is the planet that tricks people the most. In movies and video games, it's shown as Earth's backup plan, a place where you could walk around with a helmet, build greenhouses, maybe even start a colony. But the real Mars is far less welcoming. In fact, it kills you in more ways than most people ever realize. The first threat hits you the moment you step outside, pressure or the lack of it. Mars has only 0.6% of Earth's atmospheric pressure, which is practically a vacuum. You wouldn't be able to inhale anything because there's simply no air pressure to push molecules into your lungs. Just like on the moon, the moisture on your tongue and in your throat begins to evaporate instantly. Your saliva doesn't boil because of heat. It boils because the pressure is too low for liquid water to remain stable. Your blood stays intact thanks to your skin and internal pressure, but you still lose consciousness within 15 to 20 seconds as oxygen drains from your bloodstream. Then the cold sets in. Mars is freezing, not like Antarctica cold, but alien cold. The average temperature hovers around 63 degrees Celsius, and in some regions it can plummet to 140 degrees Celsius at night. Since the atmosphere is so thin, it offers almost no insulation. Your body loses heat far more quickly than it would on Earth. Skin exposed to Martian air begins to numb within seconds, and frostbite sets in rapidly. Given a few minutes, hypothermia becomes a certainty, and even if you manage to endure the pressure and the heat, the atmosphere alone would complete the task. Mars consists of 95% carbon dioxide and contains very little oxygen. Even if you attempted to inhale, lack of oxygen would swiftly incapacitate your brain. Numerous individuals are afraid of Mars's notorious dust storms influenced by intense movie portrayals. However, the truth is not the same. Martian storms are massive, at times covering the whole planet, but the atmosphere is so sparse that the winds hardly affect you. A 100-kilometer-h wind on Mars resembles a soft breeze on Earth. The actual threat lies in the dust itself, extremely fine, sharp, and potentially harmful. Breathing it in would harm your lungs and eyes, but you wouldn't live long enough for that to be significant. Ultimately, Mars eliminates life via a lethal mix of asphyxiation, lack of oxygen, and swift freezing. It's quieter and less dramatic than Venus, but every bit as lethal. The friendly red planet is friendly only from a distance. Jupiter. Jupiter isn't just a planet, it's a world-sized monster made of gas, storms, and unimaginable pressure. Unlike solid planets, you can't land on Jupiter. There's no solid Earth awaiting under those spinning clouds. Rather, plunging into Jupiter resembles jumping into an infinite sea of poisonous gases, immense pressure, and increasing heat. This plunge is undoubtedly one of the most terrifying methods to perish in the entire solar system. Your adventure starts in the upper atmosphere of Jupiter, where clouds consist of small, pointed ammonia crystals gliding through chilly air, frigid enough to immediately numb your skin and freeze your lungs if you attempt to inhale. Yet, breathing isn't possible since there's a lack of oxygen. In just seconds, suffocation starts to disable your brain. You lose awareness rapidly, well before the actual nightmare starts. As you fall deeper, you enter the pressure zone. Jupiter's atmospheric pressure increases at a pace unlike anything on Earth. Every meter down is another step into a thicker, heavier, more crushing environment. Soon, the air becomes denser than water. Imagine trying to sink through a fluid so thick it behaves like a heavyweight liquid, except it's made of hydrogen, helium, methane, and ammonia. The pressure doesn't crush you instantly. It compacts you slowly at first, squeezing your chest, collapsing your lungs, and forcing gas out of your organs. But as you keep falling, the pressure multiplies, turning deadly. Bones crack, organs rupture, blood vessels burst. Your body is compressed in stages, like being pushed through an invisible vice that tightens with every second. And even though you're already long dead, Jupiter isn't finished with you. As you go deeper, you arrive at the areas where temperatures surge. These temperatures exceed molten metal, surpassing even volcanic lava. If your body somehow stayed whole amidst the pressure, an unlikely scenario, but picture for a moment being cooked, scorched, and ultimately vaporized as you descend into the planet's intensely heated core. And the oddest thing, there remains no firm ground to strike. Jupiter lacks a crust. There is no Earth anticipating you. You just descend until pressure and heat disintegrate you atom by atom, eliminated within a planet-sized mixer of gas and gravity. Ultimately, dying on Jupiter involves a gradual, horrifying plunge marked by asphyxiation, immense pressure, ammonia toxicity, and intense heat. It's not a collapse. It's a relinquishment to a world that was never intended to sustain life in any capacity. Jupiter doesn't just kill you, it absorbs you. Saturn. After the violent descent into Jupiter, Saturn might seem like a softer, more graceful giant. Its pastel rings, smooth golden clouds, and gentle appearance give it a calmer vibe. But don't let its beauty fool you. Saturn is deadly too, just in a quieter, slower, almost deceptively peaceful way. Your fall begins in Saturn's upper atmosphere, a region dominated by hydrogen and helium drifting in pale yellow haze. The cold bites instantly, freezing moisture on your skin and numbing your nerves within seconds. With no oxygen in the air, you lose consciousness quickly, long before Saturn shows its true power. As you sink deeper into the mid-atmosphere, the pressure begins to increase. Unlike Jupiter, where the pressure skyrockets almost immediately, Saturn's rise is slower and more gradual, but slow doesn't mean safe. Eventually, the pressure becomes too much for the human body. Your lungs collapse under the weight of the thickening gas. Blood vessels rupture as the external force becomes overwhelming. Any air trapped inside your stomach, sinuses, sinuses or chest compresses violently until the gas pockets implode. Saturn doesn't attack with sudden brutality. It squeezes you steadily, layer by layer. One small mercy: Saturn lacks the dense ammonia cloud layers that make Jupiter chemically painful. There's less irritation, less chemical burning, but it's a mercy that only matters briefly, because the deeper you fall, the more severe the conditions become. Eventually, you enter the deep atmosphere, and the calm illusion disappears entirely. Temperatures soar into the thousands of degrees, hotter than any furnace on Earth. By this point, the pressure is so intense and the heat so extreme that your body can no longer exist in its normal state. You're compressed, shredded at the molecular level, and effectively blended into the planet's hot, metallic hydrogen interior. If plasma-like sounds dramatic, it's because Saturn truly transforms you into something unrecognizable. In the end, Saturn kills with a mix of freezing, crushing, and finally cooking. A slow-motion version of Jupiter's brutality. It's slightly more peaceful, slightly gentler, and slightly slower, but still absolutely fatal. Uranus. If Jupiter acts as a pressure cooker and Saturn represents a slow, crushing fall, Uranus is entirely different, a frigid tomb silently floating through the solar system. It is the iciest planet known to us, lower than those found on faraway Neptune. On Uranus, death doesn't shout, it murmurs. Your entrance into the atmosphere of Uranus may appear tranquil initially. The planet's pale blue glow comes from its upper layers made up of hydrogen, helium, and methane. However, that same methane renders the air immediately lethal. There is no oxygen available for your lungs, and with the sparse atmosphere, your chest cannot take in air. You choke almost instantly, well before the planet's icy cold completes the task. Then the chill hits with full intensity. The upper atmosphere of Uranus is cryogenic, even colder than liquid nitrogen. Your lungs and throat become frozen inside, creating small ice crystals that damage sensitive tissue. Skin hardens instantly, turning fragile and colorless. Even your eyes are affected. The liquids within freeze and become opaque, instantly blinding you. As gravity pulls you down further, the circumstances deteriorate. Uranus lacks a solid surface, consisting only of layers of increasingly dense, unusual substances. The gases surrounding you transform into supercritical fluids, existing as neither liquid nor gas, creating a chilling, suffocating atmosphere that gradually compacts your body. Bones break, organs fail, and your body turns into a compact, icy mass. It's not a brutal ripping, but a persistent, apathetic squeezing that gradually goes on to dismantle you internally. Uranus ends lives in an exceptionally quiet manner. There is no blaze, no abrupt collapse, no fierce detonation. Rather, it's a blend of immediate asphyxiation, rapid cooling, and gradual, unavoidable compression. It's a quiet, icy death, a reminder that in the outer reaches of the solar system, cold can be just as deadly as heat or pressure. Neptune. Neptune is the extreme storm of the solar system, a planet characterized by intensity and constant activity. In contrast to Uranus, which ends life silently with frost and pressure, Neptune is tumultuous, disorderly, and relentless. As soon as you step into its environment, the planet reveals its lethal character, with winds swifter than any hurricane found on Earth, almost Mach 2, powerful enough to rip through clothing, mutilate exposed skin, and fracture bones. If taken unprotected, you would be thrown through the air like a piece of paper, powerless against forces that exceed human tolerance. The chill is yet another deadly element. Neptune has lower temperatures than Uranus. If your skin or body fluids are exposed, they freeze nearly immediately, and inhaling the frigid, oxygen-depleted air would harm your lungs instantly. Suffocation occurs rapidly, and the intense cold guarantees that your body is dulled and weakened before pressure and wind can complete the task. As you go deeper into the atmosphere, the surroundings become increasingly unfriendly. Neptune mainly consists of hydrogen, helium, and methane, which are gases that are toxic and cannot support life. The increased density of the atmosphere contributes to weight and drag, rendering it almost unfeasible to move or maintain your balance. Each moment reveals you to greater, overwhelming pressure and harmful chemical makeup. Pressure mounts continuously as you descend. In contrast to Venus's abrupt impact or Uranus's gradual squeeze, Neptune's pressure slowly compresses your form. Your lungs cave in, blood vessels burst, and gas pockets burst, compressing your body into an unrecognizable mass. Well before you get to the planet's hotter, deeper layers, your body has been obliterated by a mix of freezing, crushing, and overwhelming mechanical pressure. Neptune doesn't merely kill, It pounds, chills, and constricts all at once. The mixture of hypersonic winds, freezing temperatures, asphyxiating gases, and rising pressure creates one of the most lethal environments in the solar system. It's chaotic, ruthless, and frightening, an appropriate conclusion for the final of the large gas giants. Death on Neptune is absolute, harsh, and inevitable. Bonus: Pluto. Pluto might not officially be called a planet anymore, yet it remains far too intriguing and perilous to overlook. The dwarf planet resides on the outer fringe of the solar system, a small realm of ice and stone, enveloped in an atmosphere so sparse it's nearly absent. In reality, Pluto's atmosphere functions almost like a vacuum, providing none of the shielding that Earth offers against the brutality of space. Step onto Pluto's surface without protection, and death arrives swiftly. You are unable to breathe, as there is just no oxygen available for your lungs. The absence of pressure leads to the immediate evaporation of bodily fluids, such as saliva and the moisture found in your lungs. In 10 to 15 seconds, your brain lacks oxygen, causing you to lose consciousness. The body doesn't burst, yet it's far from secure. The vacuum starts to quietly extract your tissues, and your internal organs begin to malfunction. As if that wasn't sufficient, the chill on Pluto is intense, which is cooler than any location naturally occurring on Earth. Unprotected skin, eyes, and soft tissue freeze nearly immediately, rendering your body rigid and immovable within just a few minutes. In the end, Pluto kills much like the Moon does with vacuum-induced asphyxiation, but it adds the bitter bonus of extreme cryogenic freezing, silent, quick, and icy. Death on Pluto is a cold reminder that the outer reaches of our solar system are as unforgiving as they are remote. Every world in our solar system has its own unique fingerprint of death. Mercury roasts or freezes you depending on which side you land on. Venus crushes and cooks simultaneously. The Moon suffocates silently in a vacuum, while Mars slowly drains the oxygen from your body. Jupiter swallows you into a crushing, boiling gas ocean, and Saturn freezes and compresses you into oblivion. Uranus kills with cryogenic suffocation and slow, relentless pressure. Neptune shreds and freezes you with supersonic winds and atmospheric crushing. Even tiny Pluto delivers a frozen, vacuum-induced demise. What's remarkable is that these deadly environments reveal more than just that space is dangerous. They tell the story of each planet's physics, chemistry, and character. The solar system serves, in numerous respects, as a gallery of extremes. By examining how these environments would harm the human body, researchers acquire essential knowledge for safeguarding astronauts, creating advanced habitats, and engineering technology for survival outside Earth. The universe doesn't operate with ill intent. It doesn't conspire against us. It merely adheres to the principles of nature, and those principles are immutable. Intense heat, overwhelming pressures, harmful gases, and fierce winds are merely the universe functioning precisely as intended. Nature lacks the capacity for negotiation, while space offers no forgiveness. By comprehending these deadly surroundings, we acquire both insight and viewpoint. The cosmos is not only immense, it is incredibly, astonishingly hazardous, and this is just the start. The solar system is brimming with enigmas, and if you appreciated this thorough scientific investigation of planetary demises, keep watching. The cosmos is much larger, much weirder, and much more intriguing than many of us can conceive.